Hello, this is Julian and I'm here to teach you about. Hello, this is Eric McCartney, here to teach you about covalent molecules and polyatomic covalent ions. So, a covalent molecule is two atoms that are both missing electrons in their outer shells, sharing electrons with each other to fill the outer shell to make them stable. So, for my covalent molecule example, I have silicon 2, fluorine 2, hydrogen 2. And now, to make the Lewis dot diagram, you have to figure out which atom has the most spaces in its outer shell for new electrons. And since silicon has 4 electrons in its outer shell, it has 4 spaces. Fluorine has 7, which means it has 1. Hydrogen has 1 space in its outer shell because it has 1 electron in its outer shell. This means silicon is going to go in the center. So silicon's going to go in the center then. And since there are 2, we need to put them next to each other because of that. So since the silicons have 4 outer spaces, I want to make them share 2 electrons with each other, which means in total, silicon will gain 2 electrons to this outer shell from sharing it with the other silicon. And to show this, I'm going to have a double bond, which is 2 lines. Now we need to attach fluorine and hydrogen to the silicon. Since there are 4 open spaces total across the board, 2 on each silicon, we can do that perfectly since there are 4 leftover atoms. So we're going to attach fluorine here and here, a hydrogen here and here. And since we only need to change one bond, we need to have a single bond because they're only sharing 1 electron with each other. Now fluorine, since it has so many electrons, it has unshared pairs, which are pairs that don't have any electrons to share with other atoms. And those are going to be demonstrated here in the diagram. Now this is a stable molecule since none of the atoms have any spaces in their outer shells for electrons to come and mix and mingle. And as another note, covalent bonds are actually the strongest bonds out of all the bonds, ionic and hydrogen. Now to teach you about polyatomic covalent ions, we have Buford. Now polyatomic covalent ions are different. Now polyatomic covalent ions, unlike covalent molecules, can actually use metals, whereas covalent molecules can only use nonmetals. With that, polyatomic covalent ions will have a charge at the end result, which is different from covalent molecules, which don't have any leftover spaces for electrons. Polyatomic covalent ions actually do. Now, for an example, I have manganese, oxygen 4, -1, which means at the end it'll have a negative charge. Now, just like last time, we need to figure out the atom that has the most spaces in its outer shell, which in this case is manganese, which has a whopping 6 spaces in its outer shell. So we're just going to put that in the center. And since there are 4 oxygen, we can just surround it with oxygen like this. Now, we need a -1 charge at the end, so we only need 1 empty electron, which means, as a given, these are going to be completely full with double bonds. And that means we have 2 open pairs here, because it'll already be sharing 4. So I'll just put those here, even though you don't mind that one being a bit uneven. So for the final one, we need a missing electron, which means we don't only have to share 1, which means there will be 1 left out. Which you can do this, this, and this. But wait, there's 1 left out. We're going to represent that with the little X in red, because that's a good color. Now for the final step, we need to show that it's an ion, which means we're going to bracket this whole thing. Yep, put the whole thing in brackets. And since it has a negative charge, since electrons have a negative charge, and they have, even though oxygen still has a missing electron, it still has more electrons than it did previously. It's going to have a negative charge, so I can just put that right here on the very edge, right there. So thank you for watching my explanation on polyatomic covalent ions. This has been... Whoa, did I just record this? I don't even remember that. Well, I guess my homework's done then. Signing out, Julian Malaby.